Right now, a spacecraft is screaming into the void 24 billion kilometers from Earth. Its transmitter is weaker than the light bulb in your fridge, and yet somehow, we can still hear it. A signal is just now hitting the Earth that left Voyager 1 nearly 24 hours ago. It's been traveling at the speed of light for an entire day, and we only just received it. So how are we still in contact with it? I struggle to get phone reception in my office, and yet NASA still receive live data from 24 billion kilometers away, and they're still sending software updates back. How is that possible? To find out, I went to NASA's Jet Propulsion Laboratory, where a team of just 10 people is keeping both Voyagers alive. The same team who have saved these probes from near-death experiences multiple times. So let's go on a journey beyond our solar system to try and figure out how NASA communicates with spacecraft billions of kilometers away. This video has been made in collaboration with Bamboo Lab, who sent me out this amazing 3D printer that I'll be showcasing throughout the video. I'm going to be printing a scale model of the Voyager probe with the Bamboo Lab H2C, and by the end of this video, you'll see the final result. In 1964, a student at JPL noticed something beautiful in the math. A planetary alignment that only happens once every 176 years. Jupiter, Saturn, Uranus, and Neptune would all line up so perfectly that a single spacecraft could slingshot between all four, using gravity to do the work. What normally takes 30 years would take just 12. NASA planned 4 spacecraft for something they called the Grand Tour. But after the moon landings, budgets were slashed for the shuttle program. They got 2 probes. That was the compromise. Each one carried on it a golden record. Images, sounds, and greetings meant to represent all of humanity.
But its primary mission was sending a spacecraft to Jupiter and Saturn. And there are 2 Voyager spacecraft. They're redundant, so in case one failed, could still get the data back from Jupiter or Saturn with a second spacecraft.
Voyager 2 actually launched first in August of 1977 on a slower trajectory to visit all 4 planets. Voyager 1 followed on a faster path to reach Jupiter and Saturn sooner. Between them, they sent the first close-up images of the outer planets, caught active volcanoes erupting on Jupiter's moon Io, something nobody expected. They made the first and only visit to Uranus and Neptune and captured the famous pale blue dot, Earth seen suspended in a sunbeam as Voyager 1 headed for deep space. And then Saturn swung Voyager 1 north, heading out of the solar system, 17 kilometers per second. No brakes, no return. It will fly on that path forever. Voyager 2 headed south, opposite direction, but the same fate. One time, NASA actually completely lost contact with Voyager 2. They had to make a desperate move to get it back, something called the Interstellar Scream, but more about that later. First, let me actually explain how we're able to talk to a machine that's further from home than anything humanity has ever built. Each Voyager carries with it a 3.7 meter dish antenna. Now it does look pretty huge, but the transmitter that's behind it runs on about the same amount of power as the light bulb in your fridge. That's all it has. It just screams as loud as it can across 24 billion kilometers and hopes someone is listening. On Earth, NASA built 3 of the largest radio antennas on the planet.
So the Deep Space Network is made up of 3 complexes. They're located around the world. There's one here in the desert of California, one outside of Madrid, Spain, and one outside of Canberra, Australia. Those are about equal distance around the Earth, about 120 degrees apart. So if I have a spacecraft out at Mars, as the Earth rotates, it can always have an antenna talking to that spacecraft.
These antennas are honestly insane. The receivers are cooled to just 4 degrees above absolute zero. At these sensitivities, even the faint warmth of the electronics would drown out Voyager's whisper.
Basically 15 billion miles, or approximately 22 billion kilometers from us here on Earth. And it takes all the collecting power of those apertures at the Deep Space Network in order to get a little itty-bitty signal back from the spacecraft.
By the time Voyager's signal finally reaches the Earth, it arrives at less than 1 attowatt, a billionth of a single watt. That's 20 billion times weaker than a digital watch's battery. Those giant 70-meter parabolic dishes gather all of the radio waves that hit their surface and focus them onto a single incredibly sensitive receiver. And even then, they can only just make contact. And it honestly gets even harder because Voyager is moving so fast that its signal gets Doppler shifted, the same effect that stretches light from distant galaxies. The team has to compensate for this shift in real time to be able to decode what Voyager is saying.
The one-way light time, so the time to the from us here on Earth to the spacecraft, is 23.5 hours, and then it's 23.5 hours back. So when I come to the office Monday morning and I send a command to the spacecraft, I see the effect of that on Wednesday morning.
Okay, so that's how we listen, but how do we talk back? Those same 70-meter dishes that listen can also shout. The signal that we send to Voyager is over 1,000 times more powerful than the whisper that we get back. All of the models that I've shown you so far throughout this video are ones that I've personally 3D printed with the Bamboo Lab H2C. And I've actually never been more excited to tell you about a product because I genuinely love this thing. I have to confess something. Before they sent it out, I had never 3D printed before, so I was a little bit nervous. But let me just say, if you want to get into 3D printing, Bamboo is the way to go. It's genuinely so easy to understand, and most of the setup is already done for you. And so I actually started out with the A1 printer that comes with this AMS Lite system. It took me maybe 15 minutes to put it together and connect it to Wi-Fi, and then it was ready to go. This is honestly the best part, because you can put multiple different filaments onto the AMS that feeds directly into the toolhead. Then you can make these beautiful multicolor prints like the ones I've been showing you easily. It just goes layer by layer and switches color when it needs to. I started out by just using the Bamboo Handy app on my phone. It's connected to MakerWorld, so you can just look up fun designs people have already made, and within one click on your phone, immediately send the files to the printer. Then you just come back when it's done and it's ready. After I had some practice on the A1, I switched over to the H2C, and honestly, this thing is a beast. This is one of the world's most powerful high-performance 3D printers. You can basically do anything with it. Just like the A1 with the AMS Lite, the H2C also has an AMS system too. But there's one huge difference. The toolhead that's inside has two nozzles. I have one filament out here that is directly feeding into the left nozzle, and then the AMS is connected to the right hot end nozzle. The toolhead can quickly switch to different hot ends for each colored filament. This means there is just way less wasted filament that gets spent on purging. A massive complex multicolor print like this huge SpaceX Starship would take a single nozzle printer like 10 days. On the H2C, this took me like 3 days. And since it has a huge print volume inside, you can basically print whatever you want. I've honestly become kind of obsessed with 3D printing since I got the H2C. I'm always making smaller props for the office or larger scale models that I can use in videos. Now that I've got the H2C, the possibilities feel kind of endless. Let me show you some of the things I've made. I made Kip, TARS, and the spaceship from Interstellar. I obviously had to make the Hubble Space Telescope and JWST. This one's one of my favorites. It's the Hail Mary from Andy Weir's book, Project Hail Mary. And as I'm sure you've been able to spot in the back, this is a 1:100 scale model of SpaceX's Starship. I of course also made the SLS rocket, and there's a Saturn V back there as well. So if you've ever wanted to try your hand at 3D printing, I genuinely can't recommend Bamboo Lab enough. Whether you get an entry-level printer like the A1 or a full production machine like the H2C, I know you'll have so much fun exploring the world of 3D printing. So click the link at the top of the description to check them out. And in doing so, you'll be supporting the channel and helping me continue making these videos for you to enjoy. All 6 of Voyager's computers combined have 68 kilobytes of memory. That's literally less than an electronic car key. Your phone has 2 million times more processing power, and yet NASA's engineers have been sending software updates to these probes for nearly 50 years, fixing glitches and broken hardware from billions of kilometers away. Each Voyager runs on 3 of these radioisotope thermoelectric generators, or RTGs. These are small nuclear batteries that are powered by decaying plutonium. When they launched, each of the Voyagers had 470 watts, but the plutonium decays a little bit more each year. Today, they only have around 210 watts left, and only 3 of the original 11 instruments are still running today. Every year, the team has to shut down another one of these instruments to save power. They're choosing which sensors to take away from a probe that's never coming home. One of those instruments, this long one here, called the magnetometer, is what confirmed the moment Voyager crossed into the interstellar space, detecting a shift in the magnetic field that proved it had left the sun's influence entirely. But keeping this connection alive hasn't been easy. We've nearly lost both probes multiple times. In 1978, someone on the ground made a scheduling error. Voyager 2 didn't hear from Earth for 7 days, and so it panicked. Its software assumed that the primary receiver had failed, and so it switched to the backup. But the backup had a broken capacitor. It couldn't lock onto the Earth. When they forced it to switch back to using the primary, the fuses blew. The primary receiver was dead. Voyager 2 was stranded on a broken backup 8 months after launch. But the engineers in Madrid, they had an idea. They started sending out test signals, slowly sweeping through different frequencies, searching for the exact adjustment that the broken receiver needed to hear them. And after hours of trying, Voyager 2 phoned home. That workaround from 1978, that's actually how Voyager 2 has been communicating ever since, nearly 5 decades on some jerry-rigged backup receiver. Things were pretty smooth for a few decades, but then both probes started showing their age. In January 2020, Voyager 2 was doing a routine calibration roll when a command delay left 2 power-hungry systems running at the same time. The spacecraft drew more power than it had. Instantly, the safety software shut down all 5 remaining science instruments to prevent a catastrophic failure. It took a week to fix because by this point, messages took 17 hours to reach Voyager 2 and 17 hours to hear back. In 2022, Voyager 1 started sending back gibberish. The system that keeps it aimed at the Earth was transmitting what looked like randomly generated data, and the cause baffled everyone. Voyager had started routing its data through a dead computer, one that hadn't worked in years. The dead machine was just garbling everything before it reached the transmitter, so they told it to use the right computer and problem solved. Then in 2023, Voyager 2 went deaf for 2 weeks. It wasn't receiving any of our messages and it seemed to be misaligned, not pointed towards the Earth. This was made even worse by the fact that Voyager 2 left the solar system headed south. This means it's only contactable from the Deep Space Network station in Australia. 2 weeks of silence, and then a faint signal. A heartbeat from the depths of space. The next day, they did something called an Interstellar Scream. They cranked the transmission to 250% power and shouted one command across the solar system: aim the antenna back at Earth. And it worked. The connection was restored. Every time something breaks, this team of 10 people somehow finds a way. After 48 years, the result has always been the same. Both probes are still talking to us. Making this video has made me think a lot about what would